acute triangle situation, or you have some type of obtuse triangle situation. And when we say solve the triangle, we mean come up with all the missing sides and all the missing angles. So you're going to be given some information about the triangle to get you started, and it's your job to come up with all the other missing parts or pieces. Where the law of sines comes from is, again, you can use either diagram. On the left you have an acute oblique triangle, on the right you have an obtuse oblique triangle, and the same argument will hold for both pictures. You know, is it not true that the sine, in the case on the left triangle or the right triangle, the sine of angle A would be opposite side H over hypotenuse C? Just picking on the right triangle on the left, right? Picking on the right triangle on the right, we would know that the sine of angle C is equal to opposite side H over its hypotenuse A. So far so good, right? Solving both of these equations for H, we would have that up here, H would equal C times the sine of A. This equation would give us that H is equal to A times the sine of C. And since they're both equal to H, that means they both have to equal each other. So C sine A would have to equal A sine C. And if we use cross multiply in reverse, you can see how we get the proportion A over sine A equals C over sine C. What I mean by that is if you cross multiply our last step, right, we get the step above that. And here we're slowly building what we call the law of sines. You can also tack onto this the missing side and the missing angle. It also turns out not only is A over the sine of A equal to C over the sine of C, it also would equal B over the sine of B. That ratio stays the same throughout the whole triangle. Did we already talk about how to properly label a triangle? Meaning if we call this angle A, the side across from that angle is little a. We've already discussed that in an earlier section, right? Okay. That's a big deal, because when you're given these problems today to solve the triangle, you have to make sure you label it correctly so you're headed in the right direction. So here's what we call the law of sines. You can just simply look at the bottom one. We can use this to help us solve triangles, right? Come up with all the missing parts and pieces to a triangle, as long as it's a side angle side or a side side angle situation. For example, use the law of sines to find all the missing parts and pieces to this triangle. So definitely you want to start these problems by constructing or drawing some type of triangle. Not necessarily needing to be a right triangle. I always simply just draw some type of obtuse triangle, or a acute oblique triangle, some kind of scalene triangle. And let's just label it ABC. And let's fill in what we know. We know that angle A is 32 degrees, which reminds me, folks, before I forget, put your calculator in degree mode right now, or make sure that it's in degree mode. We won't be working with radians today, so I got to switch mine over to degrees. So we got angle A being 32. We got angle B being 81.8 degrees. And we see that side A is 42.9. Do you see why this would be considered a side angle situation? Oh, I got that backwards. I apologize. I meant to say angle side earlier. Law of sines is for angle side. Side angle side would be a law of cosine situation. So we got to find how many missing pieces? We got to find two sides and an angle. We need to find side C, we need to find side B, and we need to find angle C. Well, angle C is where we can start, being the one of our quickest answers. Angle C, right away, we can take 180 minus the two angles that were given. 180 minus 32 degrees minus 81.8 degrees. Angle C is 66.2 degrees. So there I have all three angles. Okay. Now we'll use the law of sines to come up with our two missing sides, side B and side C, using side A. So using the law of sines, we know that 42.9 over the sine of its corresponding angle, which would be angle A, 32 degrees, equals B over the sine of angle B, which would be sine of 81.8. And we're going to solve this proportion for B, which means we'll take 42.9, multiply that by the sine of 81.8, turn around and divide that whole thing by the sine of 32 degrees. So doing that in all one step, left parenthesis, 42.9 times the sine of, here's the reason why you put your calculator in degrees now, is that the angle that you enter in will be degrees. 42.9 times the sine of 81.8, and we want to divide that whole thing by the sine of 32. And we get, whoa, that's not right. What did I do wrong?
You did sine twice.
I did sine twice. Sorry about that. Sine of 32. There we go. That should do it. 80.13 would be B. So here's one of our answers. Here's our second answer. Now we have to find side C. So again, we'll use law of sines one more time. C over the sine of C, which we found that to be 66.2 degrees. And here's where it doesn't matter to me if you use A and sine A or B or sine B. I'll stick with the original A and sine A. That'll be 42.9 over the sine of 32. So side C will equal 42.9 times the sine of 66.2. Divide that by the sine of 32. .9 times the sine 66.2, all of that divided by the sine of 32. 74.07. Okay. Law of sines. You know what it means to now, what it means by solving a triangle. It's your job, whatever it takes, to come up with the missing sides and the missing angles. Some cases like this one's pretty straightforward. Later on, not so straightforward. Questions with example 1. Here's a word problem involving the law of sines. It says two ranger stations are on an east-west line 110 miles apart. A forest fire is located on a bearing of north 42 degrees east from the western station and north 15 degrees east from the eastern station. How far is the fire away from the western station? So you have these two stations, A and B, on the same east-west line. So let's call this endpoint station A. Call this endpoint station B. And out here somewhere we have a fire. We're told that that fire, I'll label that point F, that fire is 42 degrees east of north from station A. And you remember that when we were measuring a bearing at the time, this angle right here is the one that is 42 degrees, right? That angle means 42 degrees east of north is where that fire is located. So if that angle is 42, then the angle inside must be 48. Because those two need to add up to give you 90, right? Makes that angle 48. What about another angle that we can come up with? Well, we're also told that the fire is located 15 degrees east of north from station B, so I have to imagine again a north-south line passing through point B. Let's move that over a little bit. And the 15 degrees would be where? That's this angle in here. Meaning I'm looking north, I have to go 15 degrees east to get to point F. So that angle's 15. This angle is 90. So putting those two together, you get 115. So I'm going to redraw now this triangle with what we know. Triangle itself look, or yeah, I'm sorry, 105. 90 plus 15. 105, thank you. Here we have point A. Here we have point B. Here we have point F. We know that this is 48. This has now been confirmed to be 105. And which one of these segments am I looking for? AB, BF, or AF? Question says, how far is the fire from the western station? Well, which station would be the western station? A. Point A is the western station. They want to know what is this distance from A to F. Are we okay with the triangle? You won't like that. So again, here we have a angle, angle, side situation. Angle, angle, side. We'll use law of sines. We could say that, oh, I forgot to label this. I was going to say, we need one more piece of information. We're told that the two stations are 110 miles apart, so the distance from A to B is 110. I was going to say we were missing a piece of information. Now, in order to use the 110, I'm going to need to know what angle F is with the law of sines. So I got two of my three angles right. I can go ahead and add those two together, subtract from 180, and the missing angle of our triangle, 180 minus 105 minus 48, that missing angle is 27 degrees. Now we're ready to use the law of sines to find x. You could say x over the sine of angle B, which is 105, equals 110 over the sine of 27 degrees. So to find x, we'll take 110 times the sine of 105, divide that by the sine of 27. Times sine of 105. And we'll take all of that and divide it by sine of 27. 234.04. 234.04, and in this case, that would be miles. We okay with a problem like that? Questions, concerns, comments, or complaints? Other than it's too nice outside.
We're done?
No, not that fast. We only have a couple more problems to do, but they're time consuming. Now, using the law of sines and using the two relationships that we saw earlier, we can modify our traditional formula for finding the area of a triangle. Looking at the triangle on the left or the right, And again, I want to remind you, if I refer to this angle as angle B, then we could call this whole side lowercase b, right? We know that the area of this triangle is 1/2 base B times height h. That's the traditional formula, right? Well, we saw earlier h is the same thing as what? Well, the sine of angle A would be h over c. So h was the same thing as c sine A. Right? We used that in the early when we derived the law of sines. Sine of A, did I get that right? The sine of A is h over c. So when you cross multiply, h is c times sine A. So let's take this and substitute in for the h in our traditional formula, and we can see that an alternative to finding the area of a triangle is 1/2 times b times c times sine of angle A. And we're going to also modify that as well. That's one of our three choices. I want you to notice a pattern here. The angle that you're going to use is the one not associated with those two sides. So other modifications of this formula, you could also say, well, it would be the same thing as 1/2 times A times B times sine what? C. One more. 1/2 times A times C times sine B. So any one of those could be used to find the area of your triangle. So we'll go ahead and take a look at an application problem using our area formula. This problem simply says let's find the area of this triangle. We're given side A, we're given side C, and we know angle B. So here's a side angle side situation. So picking the right one from above, area would be 1/2 times A times C times sine B. So this area would be 1/2 times side A, 34, times side C, 42, times the sine of 55 degrees. So 0.5 times 34 times 42 times the sine of 55 degrees, 584.87. 584.87. And our sides are measured in feet, so this technically would be square feet. Guys, all right so far? It gets more interesting, I promise.